Hello viewers, I'm Kausalya. Today we are going to solve problem number 8 under the topic root locus. Before that, you will get a clear idea if you go through the video of procedure to solve a problem using root locus. I'll give the link in the description. Now the problem is construct the root locus for the function, right? So this is the given transfer function and discuss about the stability. So what is our first step? Step number 1 is to locate the poles and zeros. So we all know the denominator terms are known as poles and the numerator terms are known as zeros. So now we are going to equate both the poles and zeros to 0. So first one, s plus 2 equal to 0. So the value of s is minus 2, right? And the poles are s plus 1 whole square is equal to 0. When you split this term, how can you write this? S plus 1 into s plus 1, right? So when you equate the term s plus 1 equal to 0, we are getting the value of s as minus 1. And similarly here also the value of s is minus 1, right? And the next one is step 2, existence of root locus on the real axis. So here we have to locate the poles and zeros, then only we can tell whether the root locus exists or not, right? So here, this is our S-plane, this is our real axis and this is our imaginary axis. So what are the values of poles? The values of poles are minus 1, minus 1. That is, two poles lie in the same place. So here you see I have marked using two cross marks here. And the value of 0 is minus 2. So here it is drawn as a circle. So here this is minus 2 and this is our minus 1, right? Now we have to tell whether the root locus exists or not, right? For example, let us consider this minus 2 as a test point. So to the right hand side of this minus 2, how many poles and zeros are there? So this is minus 2. The right hand side is here, right? So to the right hand side of minus 2, here we are having 2 poles. So 2 is a even number, right? So the root locus does not exist between this minus 1 and minus 2, right? Now consider a test point, let it be here, okay? Let this be some minus 2.5. So this is our test point. Now look at the right hand side of this test point. So to the right hand side of this test point consists of 3 elements, right? 2 poles and 1 zeros. So 3 is an odd number. Therefore, the root locus exists between this point and it goes till and it continues till infinity. Because even if you take minus 100 as test point, again to the right hand side of minus 100, because you see, if we consider minus 100 means this minus 100 will be lying somewhere here, right? Again to the right hand side of minus 100, how many poles and zeros? Again, the same poles and zeros will be lying. That is 2 poles and 1 0. So totally 3 odd number. Therefore, the root locus exists from this minus 2 to infinity, right? And step 3 is angle of asymptotes and centroid. So angle of asymptotes is given by this formula, plus or minus 180 degree into 2q plus 1 divided by n minus m, right? N stands for number of poles and m stands for number of zeros. So again when you look back at the problem, you see how many poles are there? Here we are having 2 poles because the maximum power of S is 2 here, right? So 2 poles and we are having only 1 0. So the value of n is 2 and m is 1, right? Now we have to substitute the values of q starting from 0 to n minus m. So what will be n minus m? 2 minus 1 is again 1. So we can calculate for q equal to 0 and q equal to 1, that is enough. So first when you substitute q equal to 0, what happens? 180 degree. So the final answer is 180 degree. And next one, when you substitute q equal to 1, the angle is plus or minus 540. Again when you subtract 360 degree from 540, the value is plus or minus 180 degrees, right? The next one is centroid. So centroid is given by sum of poles minus sum of zeros. So what are all the values of poles? They are minus 1 and minus 1. What is the value of 0? It is minus 2, right? So minus 1, this minus here and the value of 0 is minus 2 divided by n minus m is 1. So when you solve, we are getting minus 2 plus 2, that becomes 0 here. So the value of centroid is 0. And the next step is to find the breakaway and break-in points. So how to find the breakaway and break-in points? The first step is we have to calculate the closed loop transfer function. So this is the general formula of the closed loop transfer function, g of s divided by 1 plus g of s into h of s, right? So what is the value of g of s? G of s is given by this, and g of s again 1 plus g of s into h of s. We are talking only about unity feedback system, so the value of h of s is 1. The next step is we have to take LCM. So when you take LCM, both the denominator terms are same, so they cancel each other, and finally the value of the value of closed loop transfer function is like this, right? So this term is expanded in the formula a plus b whole square, right? So finally, the characteristic equation is the denominator term of the closed loop transfer function is known as characteristic equation. So here, this is our characteristic equation. So from this characteristic equation, we are finding an expression in terms of k. So how to find an expression? You see, we are keeping this term in the left hand side and we are moving these all terms to the right hand side. So here we are having a minus sign. And the next thing is, again, we are moving this s plus 2 to the right hand side part. So here it is in multiplication. So here it comes as denominator side. So this is our expression for k, right? The next step is we have to differentiate k with respect to s. So this is our expression for k, right? We have s terms both in the numerator and denominator. So here we have to use the formula u by v. So what is the formula here is v square v du minus u dv. This is the formula. So here v square, this is our v, so it is squared here, and v du, v is s plus 2 into du, that is this is our term, this is our u term, we have to differentiate this. So here this minus sign is written here as such, and when you differentiate s square it becomes 2s, and when you differentiate 2s it becomes 2, right? Then here we are having a minus sign, right? Minus. Again here we are having, u is having a minus sign. So minus into minus becomes plus here. And what is the value of u? This is the value of u, right? This minus and this minus get plus here. So write down u, and when you differentiate v, we are having only s term. So when s is differentiated, that becomes 1 here, right? Then the next step is we are just multiplying and simplifying. That's it. So here you see I am moving this minus sign inside the bracket. So these two terms occurs minus sign. Then the next step is just simply multiplying, right? By multiplying I am having an expression like this. So here minus 2s and plus 2s cancels each other, and finally the remaining terms are minus s square minus 4s minus 3 divided by s plus 2 whole square, right? So here the differentiation is over. Now we have to equate, that is dk by ds should be made equal to 0. You see, dk by ds should be made equal to 0. This is the condition, right? So here, in order to make this term 0, we have to, this expression should be made 0. Right? So in order to make this expression 0, just now tell me whether we have to equate the numerator term to 0 or denominator term to 0. For example, if you substitute the denominator term as 0, right? If this denominator is 0, what about the answer? It is infinity, right? Anything divided by 0 is infinity. So the only option is this numerator term should be made equal to 0, right? That is our next step. So here the numerator term is made equal to 0. I am taking this minus sign outside, and again when you move this minus sign to the right hand side it becomes 0. So no change in that, and finally we are finding the factors, right? So by solving this quadratic equation, the value of s is found to be minus 3 and minus 1. The next thing is we are going to substitute the value of these two values of s's in k expression, right? First I am substituting s equal to minus 3. This is our expression for k, right? Just substitute the value of s as minus 3, and finally the value of k is found to be 4, right? Then the next step is again substitute s equal to minus 1, but here the value of k is found to be 0. So only for s equal to minus 3 we are having a positive and real values of k. Therefore we are selecting that point as a breakaway point, right? Here no need to find the angle of departure and angle of arrival, because here we are not having complex poles as well as complex zeros, right? So we are moving to the final step to find the crossing point on the imaginary axis. Again here we have to consider the characteristic equation. In the characteristic equation we have to substitute the value of s equal to j omega, and the next step is we are going to separate the real and imaginary terms, right? So here j square is minus, so this becomes minus omega square, and the remaining term, this is simple multiplication, right? We are moving this k inside, that's it. And the next step is we are going to equate the imaginary term to 0. So what are all the imaginary terms? This is an imaginary term and this is an imaginary term, right? Now equate this to 0. When you equate this term to 0, finally the value of omega is found to be 0, right? And the next thing is equating real terms to 0. So what are all the real terms here? Here minus omega square plus 1 and this plus 2k are the real terms. When you equate it to 0, here just now we had find out that the value of omega is 0. So when you substitute this value here, this becomes, that is this part becomes 0. So 2k plus 1 is equal to 0. When you solve, finally the value of k is found to be minus 1 by 2. Right, since the value of k is negative, there is no crossing point on the imaginary axis, right? If the value of k is positive, then there is a crossing point. Since the value of k is negative, there is no crossing point on the imaginary axis, right? Now we will plot the root locus. So this is our graph sheet, right? The first part is we have to take the scale on x-axis as well as on the y-axis. And x-axis stands for real term and y-axis stands for imaginary terms, right? Then the next thing is we have to write the scale. Here the value of scale is 1 centimeter is equal to 0.5 units, right? Then the next step is we have to write the details, okay? Whatever we get it from the, get it by solving, okay? Pole, zero, centroid, angle of asymptotes, etc., right? So after writing these values, then we can start to draw the root locus. So what is the first point? The value of poles are minus 1 and minus 1. So here I am drawing two cross signs, right? This refers poles. And next the value of 0 is minus 2. So here it is minus 2, right? This is our first step. And the next step is existence of root locus, right? Existence of root locus we had already solved in step number 2. We can just copy it, okay? Existence is nothing but it will exist from this 0 to infinity. I'll show you by drawing a line. So here the root locus exists from this point and it extends up to infinity, right? Then the next step is marking centroid and angle of asymptotes. Here the value of centroid is 0. So here this is 0. Since angle is 180 degree, no need to mention, right? Because it is a straight line. So you can just leave it. Then the next thing is we are having a breakaway point. What is the value of breakaway point? You see here it is minus 3. Right? Then there is no crossing point on the imaginary axis, so no need to consider, right? So here in this problem we are having how many poles? We are having 2 poles. So how many root locus branches should be there? There should be 2 root locus branches, right? So what is the basic criteria of your root locus branch? A branch should be always start at a pole and end at 0, right? Now you see here we are having 2 poles at the same place, okay? That is the main thing to be considered. And the next step is there is no crossing point on the imaginary axis, so no need to consider this part. So our root locus, here you see again the root locus exists where? The root locus exists, it starts at minus 2 and it extends up to infinity. So here what we are doing is, you see a root locus branch starts at this pole and it travels, right, and here it reaches this breakaway point, right? So since this is a breakaway point, the root locus breaks, right, breaks here and turns this side and ends at this 0. Am I making the concept clear? A root locus branch will always start at a pole and end at 0, right? So here this root locus branch starts here, right? It travels and it reaches this breakaway point and it gets breakdown, and this part of the root locus branch ends at this 0. So let this be our branch number 1. Right. And the next thing is, again we are having another pole at the same place, right? So again I don't want to draw from here, because actually while marking I have to mark like this. Okay. So just for clarification, I have drawn as 2 individual crosses. So again another branch starts at here, right? So it starts at here, it travels, and again it reaches this breakaway point. This breakaway point, and this part of the branch, it travels on the negative real axis, and it will meet the 0 somewhere at infinity, right? So totally how many branches we are having? We are having 2 root locus branches. The first branch starts at -1 and ends at the 0 at -2. Right, it gets breakaway at the point -3. That is, the first branch starts at -1, it gets breakaway at -3 and ends at 0 at -2. This is our branch 1, right? And branch 2, again it starts at -1. Again it breaks away at -3 and it travels along the negative real axis to meet the 0 somewhere at infinity, right? So that's all. The problem gets over here. If you have any doubt, let me know in the comment section. Thank you.